Hello everyone, my name is Palvinder Singh. I am final year BTech student of BA College of Engineering and Technology, Jharkhand. First of all, I would like to thank Emertxe for providing me an opportunity to be a part of this internship. During this internship, I made a project IoT based home automation solution. It was a great experience. I learned so many new things which will be helpful for me in the near future. Now let's move towards the contents. It includes the topics what I learned during this internship: C programming, Arduino and simulation tools, introduction of IoT, introduction of embedded system, project requirements, project overview. I am going to discuss about all these in the later slides. C programming. It is a general purpose programming language created by Dennis Ritchie at the Bell Laboratories in 1972. It is a very popular language despite being old. C is very fast compared to other programming languages like Java and Python. C is very versatile. It can be used in both applications and technologies. In the first week, I learned about C language, and some of the basic topics that we covered in the C languages are basic syntax, keywords, data types, conditional constructs, functions, pointers, arrays, preprocessor, header files, macros, storage classes, and some of the topics covered in C++ are basic syntax, classes and objects, constructor and destructor. We use Arduino Uno, so we are going to discuss about it. Arduino Uno is a microcontroller board based on Atmega 328P. It has 14 digital input-output pins. In that 6 can be used as PWM outputs, 6 analog input-output pins, and it contains 16 MHz ceramic resonator, a USB connection, a power jack for power supply, and a reset button. It can be programmed using different IDE. Arduino IDE is used in this project. Arduino IDE supports C and C++ languages. Arduino IDE. Arduino IDE is an open source software program that allows users to write and upload code within a real-time environment. As this code will thereafter be stored within the cloud, it is often utilized by those who have been searching for an extra level of redundancy. The Arduino Integrated Development Environment software contains a text editor for writing code, a message area, a text console, a toolbar with buttons for common functions, and a series of menus. It connects to the Arduino hardware to upload programs and communicate with them. Here is a picture of Arduino IDE page screen on which the code is written. Simulation tools. PixSimLab is used for the simulation purpose to simulate the connection of peripherals with the Arduino board. Null Modem Emulator. It is a virtual port driver for Windows. We can create an unlimited number of virtual COM port pairs. In this slide, I am going to talk about Internet of Things. It is a network of physical objects that contain embedded technology to communicate and interact with their internal states or the external environment. We can access the things remotely over the internet. Suppose if we want to turn on or off the washing machine at home and we are not at home, we can easily control the washing machine using IoT. Doctor can already know how to save the patients before the patient arrives to the hospital. Significant components of an IoT system are thing or device, gateway, cloud, analytics, and user interface. It is life easier and time saving. Nowadays, IoT is widely used in many applications. Some of the applications are utilities, insurance, agriculture, factory, automobile, transport, etc. Introduction of embedded system. Any combination of hardware and software which is intended to do a specific task can be called as an embedded system. Embedded system comprises of processor, power supply, memory, and communication ports. Some of the examples of embedded systems are digital watches, washing machines, television, laser printer, cameras, industrial machines, electronic calculators, automobile and medical equipments, etc. Few characteristics of embedded system are shown in this slide. Embedded system performs some specific function or task. It is not so expensive, perform tasks that within a certain time frame. It is highly reliable and does not require much power to operate. The majority of embedded systems are compact and affordable to manufacture. Embedded systems use microprocessors or microcontroller to design and use limited memory. Now I am going to discuss about project requirements. Here we can control garden lights, temperature control of the home, and water tank level control by using Blink IoT app. For garden light control, here the block diagram shows how the garden lights will be controlled. We use LDR sensor. LDR sensor is used to sense the light. The resistance of the LDR changes as the light intensity varies. During daytime, the outdoor light is maximum. So the LDR sensor detects the light and the garden light is turned off, whereas the garden light should turn on when it gets darker. For the simulation, we use LEDs as the garden lights. The temperature control system consists of a heating resistor, an LM35 temperature sensor, and a cooler. Arduino Uno reads the temperature value from the temperature sensor and display it on the CLCD. By using Blink IoT app, we can turn on or off the heater and cooler of the temperature control system. Whenever the temperature goes beyond 35 degrees Celsius, the heater will automatically turn off. For water tank level control, we can control the water tank level by turning on or off the inlet and outlet valve through Blink IoT mobile app. When the water level in the tank is 3000, inlet switch automatically turned off. When the outlet switch is pressed from the Blink IoT app, water tank levels start decreasing. If the tank volume reaches 2000, inlet switch is turned on automatically. The water volume is displayed on the CLCD and in the Blink IoT mobile application. The block diagram of a water tank inlet and outlet valve control is shown here. Here the Arduino Uno reads the volume of the water tank and display it on the CLCD. Inlet and outlet valve control switch widgets are on the Blink IoT app where we can easily control the inlet and outlet valve. Notification will appear in the terminal when the water tank is full. Blink application. Blink was designed for the Internet of Things. It can control hardware remotely. It can store data, visualize it, and do many other cool things. Button widgets to control heater, cooler, inlet valve, outlet valve. Gauge widgets are used to display temperature and volume of the water in the tank on the mobile application. Terminal widgets are used to display the notifications whenever threshold is crossed. Like temperature is more than 35 degree, water level is full, etc. Here's the screenshots of Blink IoT mobile application where we can see the tabs. Tab 1 consists of inlet control, outlet control switches and water tank level gauge. Tab 2 shows the heater temperature control system where two button widgets and one gauge widget is there. In tab 1 there's a terminal which display the notifications. Project overview. Home automation refers to the automatic and electronic control of household features, activity and appliances. In simple terms, it means you can easily control the utilities and features of your home via the internet to make life more convenient and secure, and even spend less on household bills. Generally, people always don't stay at home. This causes the problem of home appliances not being monitored. Home automation enables people to control most of the devices remotely. This allows us to turn on the lights, lock the front door, or even turn down the heat no matter where we are. This project provides an IoT-based home automation solution using Arduino Uno board in Pixim Lab Simulator. Blink IoT mobile application is used to control the devices remotely. Connect the home appliances to the Arduino and integrate it with the Blink IoT app using Blink Cloud. We created button widgets and gauge widget to control and monitor the temperature control system and water tank level. Garden lights are controlled by varying resistance on the LDR module in Pixim Lab simulation. Temperature of home along with the level of water tank is controlled using mobile app. We obtain notification about the status of home appliances on the Blink IoT app. This is the image of simulation of our project, and here we have an LDR sensor in which we can vary the resistance across the sensor. CLCD display, LEDs which represents the garden light, TCA temperature control system, and the module which is used for Ethernet connection. We have serial remote tank in which the water tank level is monitored. This project provides a solution of monitoring and controlling home appliances and certain devices remotely. Using Blink IoT application and Pixim Lab simulator, home automation project is simulated where the LED temperature system serial tank resembles light heater cooler and water tank in real time. Blink IoT application allows user to control these devices according to user's wish, thus accomplishing home automation. Okay, this is a code which I have used in my project. Header files are used to include some of the functions that we are using in our project, such as spi.h, ethernet.h, blink simple, ethernet.h, wire.h, liquid crystal I2C.h, temperature system.h, ldr.h, main.h, serial tank.h. Liquid crystal I2C, we set the LCD address to 0x27 for a 16 character and 2 line display. Blink write function is used when the virtual pin is switched on and off. When the virtual pin is switched on and off, if it switched on, then the cooler turns on and the LCD prints cooler on. Else the cooler is off and the LCD print cooler off. Same as blink right heater virtual pin. If the heater switch is at logic high, then the heater control is on and LCD prints heater on. Else heater turns off and the LCD print heater off. Blink right is also used for inlet and outlet virtual pin to enable inlet and outlet valve and to print the status of these virtual pins in the LCD. Void update temperature reading. This function is used to display temperature and water volume as gauge on the blink cap. Void handle temperature void. It is used to turn off the heater if temperature rises about 35 degrees Celsius. If the temperature reading increases to 35 degrees Celsius and heater switch is on, then it makes the heater switch automatically off and print the LCD heater off. It also displays the notification in the terminal that temperature is above 35 degrees Celsius, turning off the heater. To control water volume about 200 liters, void handle tank function is used if tank volume is less than 2000 and inlet switch is off. Then we enable the inlet valve and LCD prints inlet valve inlet flow on. It also displays the notification in the terminal that water volume is less than 2000, turning on the inlet valve. If tank volume equals to 3000 and inlet switch still on, it disable the inlet because the water tank is full and print the LCD inlet flow off. Also it displays the notification in the terminal that water volume is full, turning off the inlet valve. Void setup. In void setup, we initialize the LCD, turn the backlight, set the cursor to the home by using lcd.clear, initialize LDR function, initialize temperature system function, initialize serial tank. In the void loop, we call some of the functions which we want to execute repeatedly, such as brightness control, handle temperature, handle tank, etc. This is all about the programming part. Now I am going to give you a project demonstration. First, we will see how we can control the garden lights. For this, we vary resistance in the LDR module. We know as the light intensity varies, the resistance of the LDR changes. So during daytime, the garden lights will be turned off and will turn on when it gets darker. This indicates that it is a daytime. This indicates that it is a daytime, so LED should turn off. When it gets darker in the evening and in night, the garden lights should turn on automatically. So this is how the garden light works. Next we will see how the temperature control system works. When the heater switch is turned on, the temperature start increasing, and we can also see the temperature in the temperature gauge. When the temperature goes beyond the 35 degrees Celsius, heater automatically turned off. When the cooler is switched on, the temperature start decreasing, and the temperature gauge displays the temperature value. The heater will be turned off automatically when the temperature goes beyond 35 degrees Celsius. We should turn off the cooler first. Now the temperature is increasing. If it goes beyond 35 degrees Celsius, it makes the heater turned off. So this is all about temperature control system. Now in the tab 2, we can also see the notification here that the temperature is above 35 degrees Celsius, turning off the heater. Now we will see about the water tank level control. Here is a cereal tank. When we make the inlet switch on, it increases the water tank level. When water tank level becomes 3000, it turned off the inlet valve automatically and displays the notification in the terminal that water volume is full, turning off the inlet valve. When we turned on the outlet switch, water tank level start decreasing. We can see this on the gauge widget and also on the CLCD. When it goes below 2000, it makes the inlet switch turned on automatically. We can see here the notification water volume is less than 2000, turning on the inlet valve. This is all about my project. Thank you.